As always, I love listening to the conversations you guys have about Kubernetes. In fact, I hold you solely responsible for my Kubernetes Raspberry Pi cluster that I built. Hey, so everybody, I'd like to add my welcome to Digital Build. Now, this session is to highlight some of the IoT announcements that were made at this year's Build and to provide some insight as to where some of these technologies can be used. Now, my name's Dave Glover. I'm a cloud developer advocate at Microsoft, and I've got to focus on the Internet of Things. And that includes things like embedded development, communications, cloud, and AI. And I'm based in Sydney, Australia. Now, you notice in my background, I've actually got a photo of the Sydney Opera House. And this photo was taken at the Sydney Vivid Light Festival, which is arguably one of the biggest IoT shows in the world. Now, my role at Microsoft is to connect with the developer community as kind of well as building technical content and kind of just to help us all understand how these technologies can be used and applied to real business challenges. So now it's also my great pleasure to introduce my guest and my colleague, Val Savenko. So Val, would you like to introduce yourself, please?
Hi, Dave. Hi, everyone. Really cool background. Hi everyone, I'm Val, and I'm part of the Fast Track for Azure team based in Brisbane, sunny Queensland, Australia. My team focuses on helping customers develop and deploy cloud solutions. The areas I focus on are all over the place, to be honest. That ranges from IoT to bots to cognitive services to apps. But IoT has a really warm place in my heart because I started my journey with IoT back when I did uni with electrical engineering. So I did a lot of circuit design, embedded system design, and interfacing. So when I joined Microsoft 2 years ago, it felt like a really natural path to dive in and do all things Azure IoT. So since then, I've been helping customers build solutions using our Azure Microsoft IoT portfolio. So very excited to be here.
No, that's great. I have to confess to being a little bit jealous. Now, for some strange reason, I ended up doing accountancy papers at university, and I actually kicked myself for not doing something a bit more engineering oriented. So good for you. Hey, so now I was on LinkedIn, and I spotted on your profile that you had just passed the IoT developer exam. So can you tell us a bit more about this IoT developer exam, please?
Yes, I was honestly so happy that I passed it. No pressure on me, but it was really exciting opportunity and experience. And when I did it, it was still in beta. So now at Build, we're announcing its general availability, which is yay, it's awesome. So it's a new addition to Azure certification. It's called Azure IoT Developer Specialty Exam. So prior to that, sitting the exam, I went through all the materials on Learn for IoT. So it ranges. It's covering topics from how to provision and manage devices, how to develop for IoT Edge, how do you monitor devices, what about security. So it's very cool because it's self-paced and all online. If you are planning to sit the exam or you just want to get a little bit more technical with IoT, I highly recommend you check it out on Learn for IoT.
Hey, no, that's great. I'm just really emphasizing that MS Learn is an amazing set of resources. It's all free, self-paced. You can do it whenever you want. Now, kind of in my experience, whenever I've done these things before, I always kind of I never knew that. I wish I knew that. So what are the kind of the things, what was kind of like one thing that you learned from going through that certification program that you thought, why didn't I know about that before? Or kind of what stood out?
Yes, we actually just had the chat with you the other day about things, and there's always this aha moments like, how did I know that? Oh, this is so cool. So for me, I had a lot of sort of theoretical knowledge around how to develop and debug modules for IoT Edge, but not so much practical knowledge. So this exam sort of pushed me to be a little bit more hands-on. So I actually found out that you can remotely debug your modules from your machine from VS Code. So all you need to do is to build your container with the debug Docker file and then expose the IP and the port on the device where you're deploying your IoT Edge modules. So then the debugger can be attached. And then from the VS Code, you're just editing your launch.json. So then VS Code can attach to the process on your container. And from there, you'll be able to see all the logs, see all of the variables. So it's quite handy. And I was debugging a module the other day, and I found it really useful.
Yeah. And as I was saying to you, I had to confess, I didn't know about the debug option. I have been debugging modules, but I think that's probably a bit more straightforward as to the kind of approach that you outlined. Hey, now switching gear a little bit. Now there were a number of announcements made around Azure IoT Central. So first up, could you just perhaps explain a little bit about what IoT Central is?
Yeah, sure. So IT Central is fully managed software as a service platform, which helps you build and develop applications without the need to provision and manage the infrastructure. So you can either create a fully customized application, or in IT Central, we have a vast variety of various templates based on different industry verticals. So definitely check it out. I also point out, if you have time, please look into the 8 key attributes for IoT solution. So this is what was guiding the development of IoT Central. So it's focusing on your high availability, disaster recovery, build for scaling, etc. So if you have time, I highly recommend checking it out and implement that as part of your solution in the future.
Yeah, too right. That document is pretty useful. Now, one of the other things I really love about IoT Central is the no-code aspect. So the beauty about IoT Central is you can kind of describe the interface. You can describe the telemetry that's coming from a device, and then you can kind of map them to things like graphs, charts. You can go and set up events. You can go and set up automatic email notifications. You can extend that into flow and logic apps and things like that. So I love IoT Central, just the fact you can get on and build an application cloud side with really with minimal amount of input, a minimal amount of skills, and really just kind of draw and describe what you want to go and do with the IoT Central application. So that's pretty neat. So IoT Central is a pretty useful platform. So there are a number of announcements that were also made for IoT Central. Perhaps you could just touch on those for a moment.
Yeah, there's a few really cool things that are coming out at Build. So one of them is first-class support for IoT Edge as part of IoT Central. So if you're not familiar with IoT Edge, we will chat about it in a little bit. But it means that you can now deploy your modules, monitor all the logs that your modules are generating, as well as visualize the telemetry all from one place. So that would be your IoT Central. The team has also worked on supporting multi-device tiles. So before, you would only be able to pin a tile to your dashboard that will show a particular telemetry from a device. So now we support up to 10 devices. And from what I know, the team will be working really hard to extend that limit. They've also worked a lot on the usability of custom tiles. So if you remember in the past, when you're creating a dashboard, you'll have to pin all your tiles to the dashboard and save, look at how it would look like with the real data. So now it actually has the real data in the edit window, which is awesome. So I'm pretty excited to start playing with those features. And I've heard that there's a lot of really cool announcements coming for Azure Sphere as part of IoT Central. And I've been following your day of work for quite some time and the work that you've been doing as part of the Azure Sphere Learning Guide. So do you mind sharing what are the announcements and what are you working on in that space?
Yeah, so first of all, I appreciate not everyone is going to be aware of what Azure Sphere is. So Azure Sphere is really being built to address everyone's number one concern for IoT, which is really around device security. And I'm sure most of you appreciate that IoT security, or just security in general, is really a journey. And the biggest challenge is, of course, is that the attack vectors are constantly changing. So Azure Sphere is a microcontroller platform that is secure by default, and it's really for building highly secure devices that are resilient to attacks. That secondly kind of recognize they are being attacked, and they're able to report back up to a cloud service that, hey, look, they're being attacked. And then when you have that knowledge, then you know how to mitigate it. So then you can respond to it, and you can send down application updates or operating system updates and things like that. So that's kind of what Azure Sphere is. So think of it as these three components, and they are all responsible, working together to ensure that there is a highly secure platform for building applications. Now, I'd also recommend checking out a document called The 7 Properties of Highly Secure Devices. Read through that, and then you'll have an understanding what we're trying to mitigate and the approaches that we're trying to do, that we're implementing to mitigate against security attacks. Now, Azure Sphere is made up of 3 components. So there is an Azure certified microcontroller. There's the Azure certified operating system, which we're going to provide updates. And there's a cloud service called the Azure Sphere Security Service. And now all those together implement as part of that kind of overall security to mitigate against security attacks. Now, on an Azure sphere, everything is locked down by default. So even access to peripherals, so for example, a GPIO or I2C or SPI or things like that, they are all completely locked down. So you need to whitelist all those resources that you want to use. Now, you also need to whitelist all the network endpoints that you want to use. And that's what I'm going to talk about a little bit about in IoT Central, what we're doing about that. The other thing with Azure Sphere is you can support what we call high-level applications. So Azure Sphere is a multi-core environment. We have what's called a high-level core, and that's actually running a custom version or custom implementation of the Linux kernel. On that, you can run what are called high-level applications, and there are two cores, two Cortex M4 cores, where you can also go and run real-time applications, which I'll talk a bit more about later as well. So just keep in mind, you can run high-level applications as well as real-time applications. So the things I want to touch on that are new from an Azure Sphere perspective in IoT Central. So there are a couple of things. So the first thing is that there is now an Azure Sphere template, device template. So when you go into in IoT Central, I should say, that there is now an Azure Sphere template. So when you go into IoT Central, you'll see there are lots of different templates for a whole range of devices. And they are there to make it simple to get on board with, say, hey, look, I want to stream telemetry from an Azure Sphere. So you basically go and click on that, and that'll bring in some sample telemetry, kind of like a canonical device, for example, as well as some sample source code that you have access to. So it's part of the Azure Sphere SDK. So the main thing is now inside IoT Central, there is an Azure Sphere template that makes it super easy to go and just create an application around Azure Sphere, then go and chart that information and do things like that. Now, the other thing that we've also introducing are some new tools for whitelisting the IoT Central network endpoints, because you need those inside Azure Sphere to whitelist the application that you're building. So if you didn't whitelist the Azure IoT Central network endpoints, the Azure Sphere would not be able to talk to IoT Central. So there's some new tools that are available just to kind of make that whole process a lot simpler. Now, there was also some work that we've done to kind of bubble up some of the event notifications out of the Azure Sphere security service as well into IoT Central.
Awesome. Well, I'm pretty excited to get my hands on it. I do have an Azure Sphere dev kit just right behind me on the shelf. So pretty excited to try it out. And I've also spotted there have been some announcement around the general availability of Azure RTOS. Could you tell us, Dave, what Azure RTOS is about, or what in general RTOS is, to some of us who might not be familiar with it?
Yeah, sure, Val. Hey, so if you're not that familiar with an RTOS, first of all, it stands for Real-Time Operating System. And you typically find these, not exclusively, but a lot on microcontrollers. And the role of a real-time operating system is to provide real-time services to make it easier to go and build applications which are particularly timing sensitive. So for an example, you might have an application which has a sensor connected to a microcontroller, and that microcontroller might fire an event or trigger an interrupt on that microcontroller. Now, that microcontroller would need to respond to that interrupt or be able to service that interrupt within a specified amount of time. And if it doesn't service that interrupt within that specified amount of time, then the system kind of fails. So that's kind of one of the roles of a real-time operating system, is to make sure that there are threads available to be able to go and service, critical pieces of code in the right amount of time. So just over a year ago, ThreadX joined the Azure IoT family and is now known as Azure RTOS ThreadX. And it provides application services such as real-time threads, thread interop, inter-thread communications, thread synchronization, queues, fat file system. There's even a library there for GUI. So if you want to go and define some sort of graphical user interface for your solution, there's GUI libraries as well as a graphical user interface designer. So that's pretty neat. Plus there's network interstate and USB host and device support. So it's pretty neat. Now, I was pretty amazed to go and read some of the numbers about about ThreadX, which is now this Azure RTOS. So it's been around for over 23 years. It's actually out in 6.2 billion devices worldwide. And you'll find the code in printers, popular fitness trackers, medical devices, even in things like the Bluetooth chips inside your mobile phone is almost invariably running a bit of ThreadX code. You can have it as a super small memory footprint, so it will run in as little memory as 2K bytes and run in a 20K byte off a 20K byte ROM. So it's really super slim. Obviously, you can add an additional component. So by the time you add in network stacks and things like that, that will add about another 50 kilobytes and things like that. But you can see it's really targeted at very small microcontrollers to provide that flexibility and that kind of developer space for building applications that are real-time capable. It's also certified for medical, automotive, and railway. And the really cool thing about it is now all the source code is available on GitHub. So if you head off to azure.com/RTOS, you'll find out more about it, plus a link off to the GitHub where you can see the code. The code's there for you to go and use, understand, test, and you can even make contributions back into it. Now, the thing that I love about Azure RTOS and Azure Sphere is that they really do complement each other. So you can build an Azure Sphere application, like a high-level application, which is actually really a POSIX application, interesting enough. But you can also go and build real-time applications now with Azure RTOS. And you can have those two applications communicate with each other. So you can have the Azure RTOS application there just managing the really time-sensitive, time-critical aspects of your solution, and then have that pass information across to the Azure Sphere high-level application, which can then maybe relay that on to the to IoT Hub or IoT Central. So pretty neat with what you can do around things like that. Hey, so now Val, you mentioned before about IoT Edge. So perhaps you can just talk a bit about IoT Edge. I know you're working on it with a number of customers, so perhaps just tell us a bit about what IoT Edge is.
Yes, so IoT Edge is part of the IoT Hub service, and it sort of enables customers to do what's called edge computing. If you think of it in a way, it extends the capabilities and the functionality of the IoT Hub but to the network's edge. So customers can run machine learning models, do data processing, run custom models, or even Azure Cloud Native services like Azure Stream Analytics or Azure Blob Storage on the edge. So this is awesome. And you can either build custom modules, or we do also have a marketplace in Azure where you can find out all the modules that have been put up there. So one of the ones that I've recently worked with was the OPC publisher. So as part of the Edge, you have that ability to do protocol translation. So we have a lot of devices in the field that might not necessarily support IoT Hub protocols like HTTPS, MQTT, or MQTT, and they need some type of a middleman in between that can get the data, do the protocol translation, maybe potentially data aggregation, and then send data into the Azure. So under the Azure Marketplace, you will be able to find the OPC UA Publisher module, which you can bring to your gateway device, configure it to talk to your downstream devices, and you can get the data from them to be published into Azure. So it's quite handy.
Okay. That's pretty neat. So it's great to see X509 security support built into IoT Edge. Now, one of the other security announcements that we made for build for IoT, the IoT world, is something called Azure Private Link. Now, what that means is that Azure IoT Hub now joins, or now can be joined into that world of Azure Private Link. So you could have your own virtual network that extends from your corporate to your organization's network into the Azure data center, and now have Azure IoT Hub participate in this private network or private virtual network. So that means it's just a way of really mitigating the risks that around of potentially having an IoT Hub that's exposed out through a public endpoint on the internet.
Yeah,
go for it.
There's also on Sam George's session, there was a question around support for the device provisioning service as part of the private link. So the team is working on it, and it will be hopefully available shortly.
Yeah, so that's pretty neat. And so look, I'm just going to touch on one last topic because we're kind of running out of time. The last topic I want to touch upon is do check out something called Azure Digital Twins. Now, we bought version 1 out last year, so we've just brought out version 2. So the first version was very focused on what was called smart spaces. So think about smart use of office space, for example. But version 2, the main criticism of version 1, it was very tied to a specific domain. Now, version 2 allows you to go and build custom domains. So, for example, now there is a modeling language called Device Twin, the Device Twins definition language, where you can go and model your own domain-specific scenarios. So, for example, you can go and model a factory or an energy supply network or transport network and things like that. So if you looked at Azure Digital Twins version 1 and you thought, I wish it did more than just smart spaces, do check out the version 2 because there's now a definition language where you can go and describe pretty much anything and then build a model of that and then map the physical world really into your business solutions. So that's kind of pretty neat. So yeah, hopefully that kind of gives you a bit of a sense of what you can do around digital twins. So really kind of as a bit of a wrap, I'd really like to thank you, Val, for being part of the show today. It's really awesome to have you here.
Yeah, thank you so much. It was my pleasure, and thank you for everyone who came in to listen us chat. I'm still trying to figure out my Twitter game, but you can come and say hi to me at Vale Savenkar. And what's your Twitter handle, Dave?
Hey, yeah, and my Twitter is dglover, so easy to remember, dglover. And also follow me on GitHub, and I'm Gloveboxes on GitHub. And be sure to check out the Sam George's IoT Roadmap talk that played a couple of days ago. We're also going to be releasing a lot of content onto the Technical Communities blog. So if you follow that, so there's an IoT section on that. And Olivia Block is going to be running a whole stack of content on the IoT show next week. So do keep an eye on that. There's lots of more detail as to what's been announced this week, and you'll find a lot there. So, hey, thank you very much for joining us. I'm now going to hand back to Aaron and Rick, and enjoy the rest of Build. Thank you very much.